Hell Judge Academy, and this is an academy where we learn so many things in science, mathematics, and other related subjects or courses. But for today, I'll be looking at physics practical. Physics practical is one of the important areas where students need to pay attention to in SSC exams. And we have to also know that this in physics exam, SSC exams, we have the objective part, the objectives, then the essay, which has part 1 and part 2. We also have the practical. And in the objective, this is 50 marks. There are 50 questions for 50 marks. The part 1 has 50 marks. The part 2, 45 marks, making a total of 60 marks. Then the practical, 50 marks. So a student that wants to get an A must pay attention more to the practical side of the physics. Apart from the essay, have to pay a good attention to the practical. And in the practical, you have to know that there are always 2 questions. Each question you have question 1, question 2, question 3. You have to answer 2 out of these 3 questions. In question 1A, this carries about 21 marks. 21 marks. Then the B of it carries 4 marks, making it 25 marks. So, and that's how you have to answer to get the total 50 marks. So, this part B for the practical in each question, you always have a short essay question based on what you have been given in the practical. So, now the major part in this practical is how the experiment. Let's look at the experiment itself. So, let's look at the experiment. Well, there are 2 types of experiment or 2 types of practical that we may have. The first one we can say is a real life experiment where you have to conduct the experiment in the laboratory with some certain apparatus given to you, some materials are given to you. You conduct the experiment in the laboratory and you take your readings as you are conducting the experiment. So that is one part of it. The other part is let's call it real life practical. The real life practical, and the other one is alternative to practical. The only difference between these 2 is that the alternative to practical, you are not making use of any laboratory apparatus. The whole thing has been recorded or has been fashioned in a way that you just need to take your readings from the book given to you, the exam paper that has been given to you. You only need to take your ruler, measure, then take some readings from what the diagram that they have given you. That's the only difference between the alternative to practical and the real life. In the real life practical, you have to take all the apparatuses and start looking at how to take the readings and so on and so forth. But in alternative practical, all the diagrams may be given a diagram where the time will be T1 will be here, T2 will be here, T3 will be here. So you have to read the values of this time in that in the book you are giving. So that's alternative practical. Another difference between the real life practical and the alternative practical is when you're giving in real life practical, the precautions are always in past tense form. If I'm for an experiment on mechanism now, if I'm going to say the precautions under real life practical, I would say that I avoided or I ensured I avoided error due to parallax while reading the meter rule or while taking readings on the meter rule. But if I'm going to do the same experiment with under alternative to practical, I'm going to say that I would avoid error due to parallax when taking reading on the meter rule. So the tense you're going to use there is I avoided, past tense, and this one will be I would avoid. So this is a futuristic, what you're going to do if you are to sit for that practical. So this always comes out, the real life practical always come out in the school exam for those that are in secondary school and are about to finish their journey in the secondary school. So at the end of the whole journey, this is when they have to do with the real life practical. But in alternative practical, you always see this in GCE questions or GCE examinations. So that is that about the experiment. So in each of the experiments, either the real life practical or the alternative to practical, you are going to be given the diagram. The diagram is the guide for you. So any diagram you see, make sure you look at it very well. Make sure you make yourself in tune with the diagram. You understand the concept of the diagram, and you are to use the diagram to set up the practical in real life. So whatever the diagram has that has been given to you, you make use of it to set up your real life practical. That is in a case of real life practical. So everything, the guides are given to you under real life practical and alternative to practical. Now, you do not need to copy, do not copy the questions, don't copy the method, don't copy the procedures, because the procedure for getting your results are already itemized. They are already outlined in the paper or in the guide, in the question. You're going to see you are provided with so. Then carry out this experiment for 4 iterations and other 5 values of so. Now these are kind of things that you will see. So it's not necessary to copy the diagram or the procedure for the experiment. So the first thing that your examiner is going to look at is the table of values. So we call it, when we're marking, table of values, table of reading or table of values, any way you call it. So this carries majority of the marks in your practical, and this way you take you perform. The examiner is able to detect whether the examiner is not there, but from your table of value, if you understand what you have done, if you have performed the experiment or not. So he is going to be judging the student based on the data or the readings that you have given to him. Now, and one of the things you have to also note is consistent data. Now, in some cases, if you are given a kind of diagram, let's look at consistency. So under this, the examiner will be looking at consistency, consistent data. I have an experiment of, let's say, length against time in second and period. So after getting my time, let us even use just these two. I have the length in centimeter, the time in seconds. So we have let's say 130.00, 120.00, 110.00, 100.00, 90.00. Number one thing that I did here is, now for the time, let's look at the first one at 45.7. Let's say 45.7. Let me look at the 38.7, Then we are also at 41.5. We are also at 29.0 and 34.0. This kind of data is going to be marked wrong because this data is not consistent. You can see it was decreasing from this, it decreased to this, then you just saw an increase again. This increase, a decrease, an increase. So this is not a kind of practical, this will not be accepted. So it's going to be marked from this whole table. You have lost the value for this whole table in this case because you are not having consistent data. Is either your data is decreasing or it is increasing in value, and that is one of the things the examiner will always look at, because in this kind of experiment it's always noted that the time decreases. So a correct data will be, if you are giving the time, it should be decreasing. You should be having maybe 45. You started from 45.7, 41.0, maybe 39.6, and so on and so forth. It should decrease, not increasing and decreasing at the same time. And there are some practicals that even if it's like this one now, if this one keep on increasing, if this is increasing for this kind of practical, for a pendulum practical, the bigger the length, the longer the length, the shorter the time. So you are having a practical like this, and it started from 29, and you see an increase in the time. That this is a very long experiment, so you won't get your mark for that table, that particular column. You are going to lose the mark for this because you have conducted a wrong experiment. Another thing that you also need to look at, so for this one I will give it a plus. Let's say I still continue writing 35.2, let's say then 31.5. This one now, the mark will be given to the person, so the person has the mark for that table. Now another thing we also need to look at, there are some data that are not also, that are neither ascending or descending, e.g. for temperature and or something like let's look at, not temperature now, this practical when you are looking at the angle of incidence and the angle of deviation. If you are looking at angle of the incidence, I theta, then D in degrees, I in degrees, D in degrees, and this 39 we have something like 45, this one 45.0, 50.0, 60, 55.0, 60.0, 65.0, and in this case you are having something like 39.9, 29.9, 38.8, 35.5, 37.6, and 38.5. This is possible in this case because in an experiment for this time you will have a curve for a triangular prism. During triangular prism experiment, the angle of incidence, where it meets with the angle of emergence, that's the minimum deviation. So this is the kind of graph you have. So you can see it first decreasing and also increases. So for this is going to be marked because of the kind of practical it is. The experiment, that's what is observed during the experiment. So it's always increasing and decreasing. So but if for other practicals there's always a certain trend that you must follow. So you will see the marker might, the examiner might say if it follows so trend, maybe as this one increases, this must decrease or increase. Then when you are tabulating your readings, so you must make sure that you have the whole table on a line, not having a part here, then you break the table to the next section. So you don't break the table. Make sure the table is a composite table. Everything that you are asked to record, evaluate, determine or calculate should be on that table. So all the columns must be on one table. So each column must have a heading, which is the symbol of the physical quantity being given or being determined. So you must have heading. You can see in my own case, I have heading for this, and the units also, especially for fundamental quantities like length. Length, the unit is centimeters. Time, the unit is what? In seconds. So all this must be noted. Then there are other areas where the examiner also looks at. The examiner looks at the consistency in the decimal point or significant figures. Now let's look at a situation where this same result, if I have this, let's say for this, let me just take the D part because of time. So this is the D part. I wrote 39.95 here, then I wrote 38.8 here, I wrote 35.01, I wrote 37.6. This is inconsistent. So this is inconsistent, and so it's going to be marked wrong, because each one that is inconsistent there will be marked out. That this is marked out and this, or this and this. And if the question is just carrying one mark, each one you miss here is minus half. So you have lost the table you have lost the mark for that table, for that column. So you have to note that also. Now we also look at when values, like, you have to note, okay, let me use the marking guide. This is the WAEC marking guide. This for 2019. Now, general notes. Each question, you will see that each question carries 25 marks. I've explained that, and you have to also note that each question that is may be given this observation. We may have something on observation, something on graph, slope. We have deductions, accuracy. We may ask you to find accuracy, precaution, deduction or evaluation, precaution, and short answer questions. These most times we carry. Let me show you how the marks are always being. This most times carries 6 marks. This carries 2 marks. This carries 1 mark or 2. This also carries 1 mark. This carries 2 marks. This carries 4 marks. So if I add this is 6, 7, 8, 9, 10, 16. Out of 16, so the remaining one, this should be carrying 9 marks. So if there's no accuracy there or deduction, you may have this getting you like 11 or 10 marks. So, and if you add up this, you get 25 marks. And it's easy to get this 25 marks the moment you follow all instruction from the table. Now, number one thing, well, this is for examiners. We don't penalize twice. A penalty that is earned under one subheading. These are subheadings. If I give you a penalty here, I don't transfer that penalty into this. So you have to note that. Then wrong or missing units. Wrong or missing units attract a penalty of half mark each. So if, let's say, I did not put the unit for the time here. For not putting the unit of the time here, there will be a what? No unit. I'll have no unit minus half. I'll remove half mark from the table. So no units, I remove half mark from the table. But there is no penalty for derived unit. Let's say a kind of derived unit like length inverse. Find the length inverse. So there's no penalty. It's a derived unit, or let's say something like log L. Log L is a derived quantity, so we will not mark you down for this. But every fundamental unit and quantity must fundamental quantity must have the corresponding fundamental unit. So, and that's the case of that. Then inconsistent decimal places. Let's say like this I just explained now, they are inconsistent. So you lose half mark for each values that are inconsistent. For each of the values that are inconsistent, you lose half mark for it, and this can be taken just up to 1. Please excuse me. So the inconsistent decimal place, missing heading. If you have a missing heading where you are supposed to put length, you didn't put length. Where you are supposed to put time, you didn't put time. These are missing heading. So the student will lose the mark. Will lose half mark up to 1 mark. So then you can see it here. That's why this is having 2 decimal places, 1 decimal place, 2 decimal places, 1 decimal place. So that's why I marked this wrong. Disregard of instruction DI is -1. That's loss of 1 mark. Where you are told to plot a table of I against D, I on the vertical, D on the horizontal. If you plot the table of D against I, you have disregarded the instruction, and that's what we write as DI, and that is going to give you -1. Then systematic errors attract a loss of 1 mark. Systematic errors attract a loss of 1 mark. Now, if a student, so you have to be very careful with this. If let me read it for you. Where a candidate plot values different from the values he obtained in an experiment, award 0 for plotting slope, intercept, and deductions from such graph. Now, look at this. If in this part of the world, we always have people that will just cannot conduct this experiment, and what they do is they will not bother to conduct the experiment or try out the experiment, and they just stick to what someone gave them or look at another person's experiment, which might be far different and deviated from what it's supposed to get. Now, in that case, if the student plotted something else from the value of the table of values he had. Now, someone are doing 39.95, and in the plotting, he was plotting 30, he was plotting 39, he was plotting 38, 37. These are values that are different from what he has on the table. So, what he's going to do is that he is going to lose mark. He's going to lose mark for graph, slope, deduction, even accuracy is going to be there. So a student that plotted something different from the table, so 6, 8, 9, 10, would have lost 10 marks. 10 marks. He might get the value for the table, but because he has plotted something different from what he has on the table of values, he loses about 8 to 10 marks. That's about that too. Now, then all the quantities that are read from the table, like your logarithm of something, sine, cosine, tangent, the light, all these quantities that are read, reciprocal is also part, that are read from the table must be recorded to at least 3 decimal places. So all reciprocals and logarithm and tangents and sine, angles of everything. So reciprocals and logs, sine, tan, cosine are recorded to 3 decimal places at least. So it can be more than 3 decimal places, or it can be also recorded to what? 3 SF, depending on the value. So when okay. Now there's also a clause here. If a candidate invents his or her own values, that is, these values are different from expected experimental values. We already know that the timing for pendulum is always decreasing. Now the student invented his own or her own values, which is different from the expected experimental values. So we treat that kind of case as gross error. We treat it as gross error. And in gross error, the calculation from such values under observation. So the student is going to, once gross error is noted, the student is going to lose mark from here to this place. When you invent your own table of values, or the values you gave us is different from the expected experimental values, this will be recorded as, everything I've done will be recorded as gross error. And in gross error, you lose the whole mark for observation, you lose the whole mark for graph, you lose the whole mark for slope, you lose the whole mark for deduction, evaluation, intercept. Also, you lose the whole mark for accuracy. The only thing you will have left is the mark under precautions and the short answer question. That just 6. That means you're already having 6 over 25, and that is a very big failure in that case. So we have to note that place. So everything from this will be awarded 0. Now for graphs, this general observation. Now for the graphs, you have to note that under graph, for your scales to be readable, you must make sure that your graph occupy at least 1/3. It must occupy at least 1/3 of the page. It must occupy at least 1/3 of the page. Then scales using multiples or submultiples of prime numbers such as 3, 7, 9, 13 are not accepted. So we don't use scales of multiples of 3, odd numbers. Now points should be plotted correctly to nearest half square on both sides. Let's say this is my graph box. So we always have 5. Let's see. One, 2, 3, 4, 5. Now this is the square box that we have in, and I want to, let's say I have a point here. Let's call this page 30, and this is 35. If I'm going to take a point like 32.5, I want to mark the 32.5 points here. Help me. So if I'm going to take this point, 32.5, this is 31, this is 32, this is 33. Oh, this should be 30. Let's say this is 31. 1, 2, 3, 4. There's still another one. Let's say this is the square box now. So this is 30 here. So this is 31, 32, 33, 34, 35. So in this case, we have 31, 32, 33. 32.5 is here, and we are plotting it against, let's say this is 1, 2, 3, 4, 5. We are plotting it against 2.2. We are plotting against 3. So 32.5 against 3.5. Now 3.5 is here. It's between these. 32.5 is here. Now if I mark this point, this is the correct point that I have marked. But instructions say that point should be plotted correctly to nearest half square on both axes. That means if I still record it around here, half square, or around here, or around here, or around here, still put my points here, I am still correct. I'll still mark the students correctly. Now let's say for this point now, this is the real point that I'm supposed to mark. Now in a situation where I didn't mark this, let's say, let me show you all. If I still put my point here, if I put my point here, just half of the square, anywhere around where I've just put it, anywhere I place my point around this area will still be marked correctly, and that's how we read the point. So where points have been marked, candidate can only score for axis distinguished. Now that is someone like this. Now I'm just carrying this 37, put it here, 35, put it here, 35. I'm just carrying and matching it. That kind of graphing is wrong. The only thing display we get is the axis. Now for you to get your graphs we always record, we have something like this: axis distinguished, scale, we have the points, and we have line of best fit. Axis distinguished, if we have distinguished on both axes, let's say on this axis I have marked this place and said that this place is my time, period in seconds, and my length in centimeter. Now assume that I didn't write L centimeter on my table and period, the seconds or for period on my table. Because I've seen the unit here, I will still mark you even if you don't have it here. So, but you just have to put it on both sides so that you don't make mistakes. So for this one, this is half mark. This is half mark. This is half mark. So I get 1 mark here. 1 mark here. For the scale, what we check under the scale is like where I put 30 here now, and I've counted this place. Let's say this place is 31, this place is 32, 33, 34. In another case, I'm having 5 here. Then what I just have here, I have 31 here. If 31 is here, 32 will be here, or 32 will be here. Then this one is automatically not 35. Then in that case, I have wrong scale there, so minus here, half here, so you have half mark. But this is 1 mark. Point plotted 3 marks. Then line of best fit 1 mark. So everything sums up to 6 marks. And how do we get line of best fit? Now, the first thing that we need to do now, in a situation where I'm asked to plot, before I continue, if I'm asked to plot to draw up my table, I can start with, okay, let's say serial number, that one does not carry any mark. 1, 2, 3, 4, 5. Just trying to show the iterations. I have T1, the seconds, T2 in seconds. I have period, which is T over 20 in seconds. No, T average first. You need to get the average of this. T average, T1 plus T2 over 2 in seconds. Then this is what? Period, T over 20 in seconds. Period squared, second squared in seconds. Then let's say log L. Log L. Now, this kind of table, if the student has broken this table because of space, and you broke this table around here or here or here, you broke it and brought this other three, you brought it down, you have lost mark for composite table. This is no longer a composite table. This is a composite table. All the values are on one line. All the parameters are on the same line, and all the diagrams are here. All the readings are here. But if you break it and bring this one to this side, start drawing another one, you have lost one mark for composite table. So that's that about that. Then slope. Let me quickly write the one of slope. For slope, you have the first thing is change in y, then change in s, then the first thing we have is the big triangle, delta y, delta s, and our n. So whatever you get, if your triangle is not a right angle triangle, you have lost the total mark for slope. Before you can have mark for this, and this, your triangle must be a right angled triangle. It's not a triangle that is shaky or that is bent. It's not going to work that way if you have that kind of result. So, and this takes half mark, half mark, half mark, half mark. Everything sums up to 2 marks. And that's what we have there. Now, for you to have in a case, you don't need to copy. You do not need to copy your friend's graph, because your friend might have used a different scale from yours, from what you have on your own table. So make sure you learn how to draw your graph properly, and always note when they tell you that you are plotting L centimeter against T centimeter. So the instruction would have read, like for this kind of graph now, would have read that plot L on the vertical axis and T on the horizontal axis, and that's what I have done here. So now there's another thing that we have to look for when you are drawing your graph, okay? Because one of the reasons I said you shouldn't copy your friend's graph or plot your graph from another person's reading is because if the examiner sees that your graph is not consistent with your reading, you will lose mark for the graph. So it's better you plot whatever you have on your graph, on your table, plot it like that. The only thing is you only lose about 1 mark for accuracy, and it's better to lose just a single mark for accuracy than lose like 6 marks or 5 marks for the whole graph. So it's better you choose the one that pays you. But the one that pays you is do whatever you have on your table and graph it out, rather than copying someone's graph which is not consistent, and the examiner will be able to see that, oh, you did not do this thing, or you are totally wrong on the graph. So that is worthy of note. Then when you are to draw your axis, so there are some questions that say that starting both from origin, you have to make sure that what it starts from 0, 0. In a case where you are asked to find the intercept, whether you are told to start from origin or not, the moment the question requires you to get the intercept of the graph, you must make sure you start from 0, 0. Now, if I want to draw my axis, this is how I know what to do. Now, the first thing is when you discover that all the horizontal and vertical values are positive, the horizontal values and vertical values are all positive, then your, let's say ABC is the graph sheet, 0 is the origin. This is how your graph will look like. Your graph will definitely look like this. This is the whole graph. The graph is A, B, C, D. And this is your origin. This is a kind of graph where all the values are positive. The vertical and the horizontal values are positive. Now, in a case where when all the horizontal and the vertical values are positive, yet the question requires, yes, we have the question saying that, okay, you have your table, everything you have there are all positive values. But the question now requires that you determine the intercept on the vertical axis, which should be a negative one. Then you have to make a provision for it. So let's look at when this is when let me note this. This is for when x and y values, or let me just write horizontal and vertical values are positive. This one is also when h and b are positive. They are all positive, but y-intercept is required. Then you have a kind of graph like this. So we have this is for a situation where the values you are required to find the y-intercept, which is going to be a negative value. Also, it's possible that when all the horizontal and vertical values are positive, here this question requires that you determine intercept on the horizontal axis, which should be negative. If the intercept on the horizontal axis will be negative, the graph will look like this. The graph will look like this. Now, when the vertical has both positive and negative values, while all the horizontal values are positive, then the position should, when both vertical axis has both opposite and positive and negative, you will see something of this nature. Let me just draw the graph direct. So this will accommodate for the negative values of y, positive values of y, and everything here is positive x. So that is that. Then if you are asked to look for when the vertical values are positive, while the horizontal has both positive and negative. So if you look at it and you see that the horizontal has positive and negative. Negative x, positive x. Then this one is just positive y. This is how the graph will look like. So, and so on and so forth. You have to look at all these things to determine how your graph will look like. So when you are labeling, we don't really require you to write the title of the graph. What we need in your graph is the labeling of your axis. So, and it must be close to the arrow. When I'm labeling, let's say I'm labeling this, let me take this one as, okay, let me draw now. Alright, so as t squared in second squared against against L in centimeter, very close to the arrow. So that's how to label your axis. And this labeling of your axis carries mark. I've said that if you fail to do so, you lose the mark for it. Then the heading is not necessary, but you can also write the graph of t squared second squared against L in centimeter. So this is 0.0, that's the origin. Now, to choose a very reasonable scale, you can look at that. You have to look at your values of table of values and look at the highest value and the lowest value. So with this, you'll be able to understand how to take your scaling. Now, another thing that we need to do is how to take the slope. To take a slope, when you want to take your slope, let's look at how you take your slope. I already have a graph of this against this. Let's see right, and this is t squared. I've read all my points. I'm going to draw my line of it. After plotting this, I have a straight line. Just smooth my straight line. With this, I have this point here and this point at the other side of the line. This is evenly distributed, so I'm going to have 1 mark for my line of base fit. For that, my point will be 3 marks also, and line of base fit is evenly distributed. Now to get a good slope, I don't need to mark this point to this point. I can just take a very triangle, a very big right angle triangle, and trace these values here and these values here. You trace them. So this place will be L1 and L2. This will be T2 squared, T1 squared, and this will be T2 squared. My slope equals to T2 squared minus T1 squared over L2 minus L1. So if I'm able to read these values very well, for drawing this triangle, I have half mark. But if this triangle is not, if it is not a right angle triangle, then you lose all the mark for slope. It should not be transferred to the next thing, but you lose mark for slope. Now, T2, I read T2 squared minus T1 squared, I put it here, reading it correctly and inputting it correctly, L2 minus L1, I input it here, then whatever thing I get, I record it as my slope, and that's what I record, and that gives you your two marks correctly. Now you may be also asked to, well, I'll be doing other areas when time comes. Let's look at some other things. So note, do not use another person's slope or intercept. You may be penalized for that. The mark for accuracy is very small, 1 or 2 marks. That's the maximum value you have. So therefore, losing it is not a big deal. You can decide to lose it than losing many more marks from copying or writing something that is quite different from the expected values. So then there are some questions where let us use this. We know T equals to 2 by square root of L over G. There are sometimes you may not be given, that's for advanced level now, not for the senior secondary school certificate exam. For advanced level, you may not be given to plot this against this on Y and on X axis. You may have to determine it using the theory, the theoretical mathematics, or the mathematical explanation of it. So for pendulum, this is the equation for a pendulum bulb, and in this case, so we can say squaring both sides, so we have T squared equals to 4 pi squared L over G. And in this case, T squared, if we write this equals to Y equals to ms plus C, there's no C in that sense here. So we have ms. So our Y equals to T squared, S equals to L, and your M will give us, that's your slope, which is X slope. Slope here will give us 4 pi squared over G. So after you have gotten your slope, you can get your acceleration due to gravity from your slope. So, and that's how to do all these kind of theoretical terminations. Now, okay, so I think with this, we have been able to look at the practical aspects of physics, some of the things you need to note. Let me see if there are other things that I have not said. Okay, I already said this. Origin is part of graph if requested, or if the intercept is required. So I said that before. Now for your slope, I said large right-angled triangle implies that it occupies at least 1/3 of the graph page. The large angled triangle must occupy 1/3 of the graph page for you to score the mark for slope. To obtain correct arithmetic, candidate must have read delta x and delta y correctly. Then we can accept coordinate method of slope provided points are chosen on the line drawn. Right, look at the line drawn and I just choose any line. Okay, and these are the major things. Let's look at some of the precautions under mechanisms, or let's say pendulum bob, for pendulum bob experiment. I'll just read. So each one has 1 mark, and you are required to state 2 precautions. Number 1, you can say I avoided parallax error in reading stopwatch. because you are making use of the stopwatch, the clock, or the meter rule that you are making use of. So you can avoid perilous error on. If you don't state the instrument, then you have lost the mark for the precaution. Then also you can also note, I noted or corrected or avoided zero or error on the stopwatch, clock, or the meter rule. Then also I avoided droughts. There is difference between droughts and droughts. Droughts. They sound the same way. This is the absence of water. This is the absence of air. So this is the one we are making happen. I avoided, this is the presence of air. I avoided droughts, or I switch off fans. Then, excuse me, if you when you set a pendulum into oscillation, you can say that I avoided conical oscillation. That is, you are not allowing it to move in a circular or conical way. So that's under precaution. I ensured that the support was rigid and firm. I ensured that the bulb of the pendulum was free from table. It did not touch. It's not the type that is touching the table as it is moving, because that will give you a wrong reading. Then repeated readings that are shown on the table, like in this case you have T1 and T2. Even if you don't get anything on precaution, because you have recorded T1 and T2 twice, then you have 1 mark for that. Then small angular displacement, because you want to set your pendulum into motion, then you take your pendulum this way. This is too much an angle. It's too much. It's just slight displacement from the rest position, and allow it to oscillate. And so these are few things that we need to know under this physics practical. Thank you for watching this physics practical analysis. We see in the next class we'll be touching maybe how to take readings from either a real life practical or from an alternative practical. God bless you. I remain the tutor for L. George Academy. God bless you. Please subscribe, like, and share these videos so that you can get more videos from us. Thank you. I need to.